Hello viewers, welcome to this episode with PyMath. In today's episode, we'll continue still in our series with the laws of indices. In the laws of indices, we'll look at the third part to it, and this time we'll be looking at fractional indices. But on fractional indices, we'll look at negative fractional indices. And this is important because there are certain problems we need to solve that carries a negative fractional index. You can tell your friends about PyMath, share this video, feel free and share it across your space so your friends could have them and grab one or two things from this video. You can also tell them to follow PyMath on this space and some other spaces where we showcase our videos. We'll go on now to the environment and draw a perspective on what we have for today. So in today's episode, as we said earlier, we'll look at negative fractional indices. Now, let's demonstrate this in a way that would understand it properly. All along, we've been using a base, an arbitrary number A, and we've said that if you have an index number where the base is A, okay, but this time, if this arbitrary is minus x over y, for instance, we say minus, here what we can see clearly is a negative fractional index. To express this, we need to be mindful of the negative index. And the way to do this by the law of indices is to first get rid of the negative sign in the index. To get rid of the negative sign in the index, all we have to do is to set this to be, we'll set this to be equal to, we set it to be equal to 1 all over a to the power of x raised to the power of x over y. Okay, so writing it this way helps us to get rid of the negative sign here. So for negative index, the best way to deal with them is to express it this way. When you express it this way, it helps to get rid of the negative sign from this point. Okay, so this is a classical way of dealing with negative index. Let's see some examples with this. Let's say, for instance, we are to express, let's have, again, we can have 64, this time to the power of negative 2 over 3. Okay, negative 2 over 3. So how then do we express this? So we'll follow the same principle we saw earlier on. This will be equal to 1 all over 64 to the power of 2 over 3. So all over 3. Good. So now the negative sign is off it. So what do? We come back to our initial law of expressing the denominator, because the denominator is now in the form of positive fractional index. So this becomes 1 all over the 64 in the raised to the power of 2 over 3 in the denominator. This becomes the third root of 64, or the cube root of 64 raised to the power of 2. So that's how it is. So we have, this is the cube root of 64, all raised to the power of 2, cube of 2. So this is what we have here. Then if we take one step further here, from here, this becomes, this will be equal to, this is equal to 1 all over. So if we take the cube root of 64, the cube root of 64 is 4. So that will be 1 all over 4 to the power of 2. Take this further. this becomes 1 over 16. So this equals 1 all over 16. Okay, so this is what we have. Okay, so expressing this, we get finally it becomes 1 over 16. So this is a way of dealing with fractional index or fractional indices. Okay, so we saw how we expressed it here, and we demonstrate this with an example. There are forms in which these could also appear. Let's say, for instance, we could have it like this. In brackets, we have, let's say we'll take this example where we have 81, or rather 16 over 81, 16 over 81, over 81, raised to the power of minus 3 over 4, minus, let's say, 2 over 4, 2 all over 4, or possibly 3 over 4. Let's make it. How then do we express this? We do it the same way in the last example we saw. So what you simply do to this is we're supposed to have 1 all over 16 over 81, which means the same thing as the inverse of the fraction 16 over 81. And the inverse of the fraction 16 over 81 is simply 81 over 16. So that's what it means. So this is 81 over 16. That way, we've gotten rid of the negative sign, which okay, so the negative sign is off it. So to get rid of this negative sign, we take the inverse, which is 1 all over 16 over 81. So 1 all over 16 over 81 means the inverse of the fraction. Inverting this will be 81 over 16 raised to the power of 3 over 4, which brings us back to a positive fractional index. So now we can now take, this becomes the fourth root. So this becomes the fourth root of 81 all over 16 raised to the 81 all over 16 raised to the power of 3. So fourth root of 81 all over 16 raised to the power of 3. Now give us, of course, the fourth root of 81 is 3. The fourth root of 81 is 3. So we have this to be 3. And the fourth root of 16 is 2. 16 is 2. And everything is raised to the power of, opening up this bracket, this will be 3 to the power 3. So we have 3 to the power of 3. So that's what that means. The bracket outside affects all the parameters inside. So 3 to the power 3 will give us 27. And 2 to the power 3 will give us 8. Okay? Which, if you like, you can express this further. 27. That'll be 3 times, which is 24. Okay? And we have, all right, so this is our final expression. So this is a case of fractional, negative fractional index. And we've seen how we can solve problems of this nature and how to go about them. So in our next episode, we look at more examples on, we'll take examples on all of the laws we've seen so far, how we can look at different ways in which they appear and how to solve them. Help share this video to your friends and tell them also to follow PyMaths. If you have any question, drop it on the comment section. I look forward to receiving your question. Do have a great day.